The sky is not blue, not in the way you think, not for the reason you were told. And the explanation you accepted as a child, the one that felt complete and satisfying, was missing the most disturbing part. A part that scientists refuse to believe for 2,000 years. A part that, once you understand it, makes you question whether you have ever actually seen the sky at all. By the end of this video, looking up will never feel the same again. But first, understand why this matters beyond curiosity. In 1666, Isaac Newton split sunlight through a glass prism and proved it contained every color. Scientists celebrated. They assumed the sky question was basically solved. It was not. That assumption, that Newton's work had answered it, caused scientists to stop asking the right questions for nearly 200 years. 2 centuries of misdirection, and the consequences were real. Technologies that depended on understanding how light moves through atmosphere. Early telescopes, navigation instruments, the first attempts at long-distance signaling were all built on flawed assumptions about what the sky was actually doing. Ships navigated using optical instruments calibrated on wrong physics. Observatories were built with miscalculated atmospheric corrections. The color above your head was not just a philosophical curiosity. It was an engineering problem that nobody had solved, and nobody fully admitted was still unsolved. Most people, if you ask them today, give the same answer. Sunlight scatters in the atmosphere. Blue scatters more than other colors. So, we see blue. Confident, neat, finished. But that's not the real reason. That's only the surface. Because if you actually run that logic to its conclusion, if you follow the physics all the way, you hit a wall that no one warned you about. And it is a wall that embarrassed some of the greatest scientific minds in history. Go back further than Newton. Go back to Aristotle, 350 BC. He looked at the same sky you see every morning and asked the same question you probably asked as a child. His answer was elegant. "The sky is blue," he said, "because of the depth of the air above us. More air means darker color, the same way shallow water looks clear and deep water looks dark and blue." It was logical. It was intuitive. It was taught in every serious institution of learning for over 2,000 years. Entire civilizations rose and fell while this wrong answer sat unchallenged in textbooks, confident and untouched. And this is where things get interesting. By the 1850s, scientists had moved past Aristotle, but had landed on a new wrong answer. The theory of the moment was water vapor. Tiny droplets suspended in atmosphere, scattering light the way a foggy window scatters a headlight. It explained the blue. It matched observation. It felt correct. A physicist named John Tyndall built a laboratory experiment specifically to prove it. He pumped particle-filled air through a glass tube, shone a powerful beam of light through it, and watched blue light scatter from the particles exactly as predicted. He published. He was celebrated. He was confident. Engineers learned this the hard way, because the moment anyone tried to build practical instruments using Tyndall's atmospheric model, the numbers kept coming out slightly wrong. Telescope calibrations drifted. Atmospheric measurements didn't add up. Something in the model was off, and nobody could find it. Tyndall's particles were too large. The real atmosphere didn't work with visible particles. It worked with something no one had properly accounted for. Something so small it had been invisible to every experiment run until that point. Plain air, just the molecules of nitrogen and oxygen themselves. No particles, no water, no dust, just the invisible gas you are breathing right now. And the way light crashes into it at 300,000 kilometers per second. A young British physicist named Lord Rayleigh worked out the mathematics in 1871. And what he found was so counterintuitive that it forced a complete rewrite of atmospheric physics. Sunlight is not white. It is every color simultaneously. Red, orange, yellow, green, blue, violet, all layered on top of each other. Each color is a different wavelength. Think of wavelength as the size of a ripple. Red has long, slow ripples. Blue and violet have short, sharp rapid ripples. When sunlight enters the atmosphere and strikes a gas molecule, long wavelengths pass straight through, almost without noticing the molecule exists. But short wavelengths, blue and violet, collide with those molecules and scatter. They bounce off in every direction at once, upward, sideways, downward, toward you, in all directions simultaneously. So wherever you look in the sky, not just at the sun, but anywhere, in any direction, scattered short wavelength light is flying toward your eyes from millions of collision points spread across the entire dome of atmosphere above you. That is the blue you see, not a reflection, not a color the sky has. A color the sky is constantly generating in real time from the collision between starlight and air. But here's the twist, the one that changes everything. Violet light has an even shorter wavelength than blue. By Rayleigh's own mathematics, violet should scatter more intensely. The sky should be violet, deep, saturated, unmistakable violet. And this is the part the textbooks quietly skip, because it drove physicists to distraction for decades. The equation was correct, the physics was sound, and everyone kept seeing blue. The answer was not in the atmosphere, it was in your eye. This small detail changed everything about how scientists understood human vision. Your eye contains 3 types of color receptors called cone cells, one tuned to red, one to green, one to blue. But here is what no one tells you. Your blue cone cells are also partially sensitive to violet. When violet light hits your eye, it fires your blue cones strongly, your red cones weakly, and your green cones weakly. Your brain receives that combined signal and does not interpret it as violet. It interprets it as blue. You have been seeing blue your entire life partly because your brain doesn't have a clean way to show you violet, and the universe has been quietly adding to the deception. The sun produces less violet light than blue to begin with. The outer atmosphere absorbs a portion of what violet does scatter. So by the time any light from the sky reaches your face, the violet has been stripped away at multiple layers. By the star, by the upper atmosphere, and by the specific limitations of your own biology. What remains registers as blue every morning without fail, and that's only half the story. The same scattering that gives you blue sky at noon gives you fire at sunset. At midday, sunlight drops nearly straight down through the atmosphere, a short path, maybe 100 kilometers. Blue scatters everywhere overhead. At sunset, the sun sits at the horizon. Its light now cuts across the full width of the atmosphere at a low angle, a path up to 50 times longer than at noon. Every short wavelength, blue, violet, has already scattered away miles before reaching you. What survives that brutal long-distance journey is only what was too stubborn to scatter. Red, orange, the long wavelengths that passed through everything without flinching. The sky is not changing color at sunset. The geometry is changing. And the geometry reveals what was always hidden inside ordinary white daylight. Here is the fact that will stay with you. On Mars, the daytime sky is pale pink and butterscotch because the Martian atmosphere is thin and laced with fine iron-rich dust that scatters red wavelengths instead of blue. But at Martian sunrise and sunset, when that light cuts across the atmosphere at a low angle and the red scatters away, the sky directly around the sun turns blue. An eerie, quiet, unmistakable blue. When NASA's rovers sent back those images for the first time, people stopped, because they were seeing proof that the color of the sky is not a fact about the universe. It is a fact about a specific planet, a specific atmosphere, and the specific eyes doing the looking. Every part of that equation is local. Every part of it is contingent. None of it was guaranteed. You did not inherit a blue sky. You inherited a human sky. Built from the output of one star, the chemistry of one atmosphere, and 4 billion years of evolution that shaped your eyes for survival, not for truth. Other creatures see it differently. Many insects perceive ultraviolet wavelengths your eyes cannot detect. Some birds navigate by light polarization invisible to you. They look up at the same sky and see something you will never see, cannot imagine, and have no word for. So the next time you step outside and look up at that blue, the one that has always just been there, ordinary and unremarkable, know what you are actually looking at. A star firing light in every direction. An atmosphere catching the shortest wavelengths and throwing them back at you from every angle. And a pair of eyes, ancient and imperfect and magnificent, turning all of that chaos into one clean, quiet color. The sky is blue because everything had to be exactly this way for you to be here to see it, and you almost never would have known.